Today we're going to work with the Servo I on doing the pre-use check and also setting the machine up in SIMV and assist control. First of all, we're going to do the pre-use check. I've already connected my high pressure hoses, my oxygen and my air to the wall, and the machine is plugged up to the wall. Want to show you one item while we're waiting for the machine to power up, and that is this device right here. This is your air hose, but if you look at this device right here, remember from foundations, how do we get our air for the hospital? It's through a compressor. Even though there's a desiccation or a drying agent that's supposed to get all the water out of the air, there's a possibility of water coming through, and this is a water trap. When I just found this hooked up to the wall, it was hooked up like this. Now, the water trap is not going to be effective if it is on its side. So we need to have it straight up and down with the plugs here, and this needs to be straight up and down on the wall. So if there's any water, it'll go into it. So I'll plug that back in. Now, what this is asking, if you can see, do you want to start pre-use check? Yes, we want to do a pre-use check. It'll let the internal stuff run, and it is pretty much fully automated. Will tell you what to do. When it says connect the test tube between the inspiratory and outlet and expiratory inlet, this is the hose that they're talking about. It looks something like this, and this is supplied by McKay. You cannot just use a hose that is supplied or that you cut off of a roll of large bore corrugated tubing. They say that the machine knows the compliance and stretchability of this hose, therefore you have to use it. Remember, when pushing anything on the exhalation cartridge, to support the exhalation cartridge. We want to support this right here. So when I put this on, I am supporting it here. The reason being is when you do your pressure check, if you do not support that, you could form microfractures. And when you get the microfracture, it will not pass the pressure test. That was not an earthquake. Okay, connect the tubing. I have connected it between my output from the ventilator and my return on the exhalation cartridge. Hit OK. And then it is just a matter of waiting. If you notice, the 840 asked what were we calibrating. Were we calibrating a infant circuit, pediatric circuit, adult circuit? What were we doing? The McKay, the Servo I, does not matter. When it gets down to that portion, you just need to make sure you have the circuit on that you're going to be using for that patient. You can always redo a circuit test, and you should do that every time you change the circuit on a patient. So if the patient soiled the circuit and you have to change the circuit, you need to redo a compressibility test, and I will show you how to do that. If you go from a non-heated to a heated wire, redo the test. If you go from an adult to a neonatal circuit, redo that test. The test that it is really, really quick. Takes maybe 30 seconds, and while you're doing that, the patient can be bagged. As you can see, once we hook this up, this pre-use check is completely automated. It is doing everything. We have already tested for internal leaks, barometer, gas supply, internal leakage test, pressure transducer test, and now it is doing the O2 cell sensor test. That has passed. Now we're doing a flow transducer test. One or more batteries need to be replaced. Check batteries and status for more information. We know that ideally in the hospital you would not want to use a ventilator that did not have more than about 45 to 50 minutes per battery. Connect patient circuit and block the Y. I already have a patient circuit right here. It's already on. There's my ends, and there is my Y, patient Y, that is blocked. So I'm just going to hang that up. I take that hose off. We're just going to lay it right here. And then I connect it to the inspiratory and expiratory side. One thing on the Mackay that you would want to do is go ahead and use a bacterial static, viral static filter on the exhalation side. There is nothing filtering the expiratory gases coming out of the patient. So you would want to do it. Mackay will tell you that if you do that, you can actually increase the rain out in the expiratory filter, only because the exhalation cartridge is heated, and with that expiratory filter you will drop another 2 degrees centigrade in your exhalation gas, which will cause rain out. But the problem is your expiratory cartridge does not have a filter at all. So therefore anything coming out of the patient's lungs, you are breathing it. So connect the patient, or connect it. I've blocked the Y. Where it said battery switch test and it says not completed, the only thing it would have you do is, if our batteries were good, it would ask you to unplug the ventilator from the wall so it could actually test the batteries and see how long they would last. Our batteries are not good right now, so a good battery would last about 60 minutes to 70, 80 minutes, something like that. Typically in the hospital you will replace the batteries when the battery life is no more than 45 minutes. At a minimum, the ventilator has 2 batteries on it. They are on the side, and this is what they look like. There are 6 slots that you can fill all of them up with batteries, and technically you could run this ventilator on battery power for over 6 hours. So we're doing the patient circuit test, still waiting. And that battery is where the little slot is on the side. You can put in other modules, such as the Nava module may go in there. Different modules that you could use on different patients. Okay, do you wish to compensate for compressible volume? We covered this in class. What is compressible volume? It is the amount of volume that gets compressed in here and the stretchability of the circuit. So to make sure your patients get the appropriate amount of volume, we always compensate. Say yes. We are done. We hit OK. Do you wish to delete patient data, trends, and event logs? Yes. That's your previous patient. We want to delete it. So this says PreUse check not completed. Mainly, the only reason it did not, the PreUse check is not completed, was the batteries for the ventilator. Otherwise, it would say passed, passed. But because of our battery, I'm going to say no. Because of our batteries not passing, that's why it did not pass. Now, I told you I'd show you how to redo it. So let's say you switched your circuit. Your circuit right there. If you switched your circuit and needed to replace the circuit, all you would do is patient circuit test, and there it goes. Connect patient block Y. This would be the brand new circuit that you put on. You replace the circuit, replace it with a heated wire, went from adult to pediatric, adult to neonate, or just change the circuit, period. Because you change the circuit, anytime you switch it, because you'll want to do this. The only one that the pre-use check or the patient circuit test has been completed on is the exact one that you put on. Even if you're putting the exact same circuit on, you will want to redo the patient circuit test. And this is only if you're staying on the same patient and you're changing the circuit on the same patient. You'll redo the circuit test because every circuit, even if they're the same kind, same make, same model, have different compressibility factors. And this is making sure that your patient gets the appropriate amount of volume. So this will take a couple minutes. And there's no way of speeding this up. Remember, between patients on every ventilator, when you process a ventilator, you must change out all disposable items and wipe down the entire ventilator. People will go, that's standard. But what therapists forget is when you wipe down the entire ventilator, we also mean the hoses, the electrical cord, all the way back. Everything is contaminated. Wipe down the outside of the vent, the front of the vent. Do not wipe the screen with the typical wipes because you'll actually damage the screen. Compensate, yes, and they have special wipes for that. And we hit OK, it's done. So now we're ready to set it up. One last thing on the setup of the ventilator. I'm going to pull out here. There. This ventilator, you can actually pull this out. Now sometimes, when I'm talking about water, water gets into this cartridge. This is your exhalation cartridge. You push down, lift up. I'm going to take the circuit off. The release button is right here on top. When you put it in, you put it on. This notch goes onto a bar right here. The bar right there. And when you put it on and you push here. Do not push down on this. Again, if you push here, you can get microfractures and your ventilator will not pass the pressure test. And you push it down until it clicks. It's now ready. There is a computer card that slides in here. Do not force. If you break this computer card, if you put your hands on it and make it corroded, that goes directly to the motherboard. The last number I heard was about $5,000 to $8,000 repair. So your positions will not be happy. And then this just pushes back. Now once you do a pre-use check, this ventilator is now calibrated to this exhalation cartridge. You get water in here, you cannot just change the exhalation cartridge. You will need to do an entire new pre-use check. So right now, right after the pre-use check, this cartridge is with this ventilator. The hospital will have different standards on how to process the exhalation cartridges. I know with our research, we only did it on respiratory isolation patients, such as droplet isolation or airborne isolation. And droplet would be from the lungs droplet. Other than that, we did not do any processing of it except wiping down the outside. That concludes the pre-use check for the for the McKay Servo I.